Hi, and welcome back to Waveform Science. My name's Jeff Hagan. Today we're going to be looking at the brand newly released Charger 2, which the embargo date on the video is today, actually, so this is as soon as I can get you the information. This is being announced at CES 2026, which, if all goes as expected, this is the week of CES, where I will be at CES the week when this comes out. So this is being recorded ahead of time, obviously, because I'm still at home. And I've had the device for about 3 weeks. This is based on a prototype device, not a production model. So there may be some changes between what you see on this video and the actual device, disclaimer ahead of time. Also, I use time compression in a few places in this video simply because you'll see when we get there, it takes 90 seconds to detect what you plug into it, and we don't want to sit around and wait over and over again. So you'll see when I use the time compression, but that's used pretty extensively in the test results portion of this video. But other than that, you're going to see actually what the device does, plus or minus how long it takes to do it. Thirdly, for the YouTube lawyers out there, I am not paid to make review videos. They had to send me this device because it's not out yet. It doesn't exist. You can't buy it. There's no pricing on it. We don't even know release date yet. So other than the fact that they had to send me the device to get the review out, they don't pay me to do these. I don't get commissions. I don't have discount codes with affiliate information in it. I just don't do those kinds of things. I don't make money off solar generator work. So the purpose of me making this video is because I enjoy making them. They're fun. People enjoy watching them, so I'll keep making them as long as people keep watching them, but I'm not in it for the money. So I don't work for Bluetti. I do work in tech, just I don't work in solar generators. So I've got no vested interest on whether or not this is a good device or a bad device. So we're going to see really what it does. And hopefully this will help you decide whether or not what it does is what you need it to do. When the packages arrive from Bluetti, you will see there are 3 different packages here. The first one is the Charger 2 itself. And then we've got the 2 optional accessories that we're going to be covering in this video. The Hub D1 version that connects to the Charger 2. A slightly different connector on that one than the standard Hub D1. And the battery connection cable, the P090D cable. That allows you to charge directly into the expansion battery port on one of Bluetti's expandable batteries, as well as reverse charging back to the vehicle. And we're going to test all of those. Inside the package, we've got the Charger 2 itself. We've got some mounting screws. We have an input and output cable, both of which have MC4 connectors on these. One of these is actually the output that goes to your solar generator to recharge it, assuming you're charging it in solar output mode. The other one is an input cable that allows you to run solar panels into the Charger 2. It's got a converter cable here. This has got MC4 on one side and XT60 on the other. I assume that's to connect it to all of the various XT60 solar generators that are out there. We've got the user manual and we've got a wiring harness. The wiring harness comes with a inline style fuse, which is nice because this is the thing the Charger 1 harness was missing. So now we get a fuse. On the top of the Charger 2, we have a power button here. Turns it on and off. On the back of the Charger 2, we have a couple of inputs, a couple of outputs, and a couple of communication ports. So let's go through it. First off, your input, or input and output actually, is the alternator port. That's where it's going to connect right here to the vehicle alternator system per the instruction manual from your vehicle manufacturer. The other input is the PV input. That's where it's going to connect to solar panels. If you so choose. You don't have to, but it's there. Charger 1 couldn't do it, so this does that. That's a 50 volt limit on this one. The next one is we have a D+ connector. That's strictly for communication. This is used to communicate with a smart alternator. Now I'll call out, I don't have a vehicle with a smart alternator in it. None of my cars are new enough to need that, so I'm not going to be able to test that one, but it is what it is. It's got it on there. The Charger 1 didn't have it. Next up, we've got the 2 ways to connect to power stations. That's either going to be your CHG, your charge, or your battery. You'd use one of these 2. You would not use both, and you'd have to configure in the software which one you're going to use. The CHG will charge your solar generator output through the solar input on the solar generator, similar to Charger 1. And that works on pretty much every brand of everything as long as the voltage is compatible. This one is a little bit more proprietary. That goes to the battery connector, the battery expansion port connector on Bluetti units that have battery expansion ports. This allows you to both charge and, by the way, reverse charge to and from the battery on your Bluetti expandable power station. I've taken everything out of the box and hooked it up to a fake car, which is what all these parts are. So let me cover what we've got here. So first off, we have a battery charger, which is pretending to be an alternator, which is charging effectively a car battery. This is a lithium iron phosphate battery, but the chemistry of the battery doesn't matter in this case. It's basically a 12-volt car battery, which is running through the stock harness that Bluetti gives you. I am not using the fuse. That's back here. But the reason I'm not using it is because I'm not going to walk away from it. Their fuse holder is designed to replace a battery terminal. And this particular terminal doesn't fit on that particular battery, so I'd have to get a different fuse holder. But that's just an issue of the fact that my battery is different. So I've got it wired up with that minus the fuse, but when you wire it up to your car, please use the fuse. This is the solar cable, which is hooked up to nothing right now because I'm going to demo that later. We're going to start with a simple use case. And we've got the battery chargers on. You can see the green here, it's done charging, so it's full. And I've got the output cable here is plugged into just the XT60 cable that Bluetti provided in the box, and I've got it running through a little adapter harness here just cause. You'll see why later. And then I've got a couple solar generators here. I've got a Elite 30 and a Elite 100 in the picture, just so we've got something for it to do. So that's our setup here. Effectively, the car battery is going to be running the thing as if it was an alternator. The charger is going to convince Charger 2 that the engine's running. That's why I've got a charger here. It's just to convince it that the engine's running, because it's going to keep the voltage high enough that it thinks the thing's on. And we'll try it out, see what it does. But beforehand, we're going to take a look inside the app and see what options are available inside the app. We're connected in here through the Bluetti app. You can see we're connected by Bluetooth, although there is also a mode to connect by Wi-Fi on this unit. We're using Bluetooth here simply because the prototype unit doesn't want to connect to Bluetti server right now, which doesn't really matter because most of the time when I'm traveling I don't have Wi-Fi anyway. So is what it is. We're going to be connecting by Bluetooth. We see a icon of a truck here. We can tap on the battery icon. That tells us the voltage of the mains battery, your starter battery. Bluetti battery is not hooked up right now. That would be this port right here, which we're going to play with later. PPS portable power station, that tells you how much power is going out. Right now the voltage is set to 9.6. There's actually nothing hooked up to it. Cable's right here. But it doesn't know that nothing's hooked up to it, so it is fine. DC panel, again, nothing hooked up there. But it doesn't know, so if I tap on that, it doesn't actually do anything because there's nothing there. And PV, the solar input, again, nothing hooked up right now. We'll play with that later. I can turn on and off the charging. I can apparently turn off Charger 2. There's a power button there that I can actually turn it off. It starts back up when you start the car, which in this case, for me, starting the car, I have to turn the charger on and off to get the thing to come back on. But that's because I don't have an actual car here. It just is what it is. Silent charging makes it charge slower. It does save energy statistics to the cloud. But since I'm not on the cloud, you can see there's nothing here. It just doesn't want to connect right now. I assume this will be working by the time they release it. And up at the top here, we've got the little exclamation mark. That's your alarms and your alarm history, which again, I'm assuming there's nothing there because I haven't gotten the thing to connect. Gear icon. We've got network settings to connect to Wi-Fi. We've got the Bluetooth password so that you can make sure nobody else connects to it when you're not wanting them to. Homepage display if you want this one to be on the homepage. And of course, new one, reverse charging. Let's talk about this for a minute. So what Bluetti says about this, reverse charging is not designed to jumpstart your car. It's not a jump starter. Jump starter provides something like 300 amps for, a tenth of a second to get the engine going. More like half a second. So a large amount of amperage for a short amount of time. But that's not what this does. This provides a small amount of wattage for a long amount of time, effectively to prevent the battery from going dead in the first place. So there's three modes. There's top up, which will allow the unit to top up the battery effectively. Trickle charging, you can do that whenever you'd like to. It'll just trickle charge it, similar to many other products in the market that do that. That's mostly for like long-term storage. You know, if you've got your van and you're not using it for the winter and you've got solar panels on the roof, well, the Bluetti can keep the battery up to date. And of course, pulse charging, that's what you do when a lead acid battery actually gets all the way down to 0 and it doesn't want to take a charge. You can sometimes, actually most of the time, get it to take some amount of charge by pulsing it. And it's got that mode in there too. So if you actually run the battery down to 0 and it just won't charge, it's got a pulse mode. So that's useful. It's got all of those in there. You'll also notice at the very top, there's a reverse charging enable and disable. What this means is it's not going to reverse charge unless you specifically tell it to. There's no low battery voltage detector in here that makes it reverse charge, nothing like that. You actually have to connect to the thing and tell it to reverse charge, by the way, every single time you want it to do it. That said, once you turn it on, until you start the car, it stays in reverse charging mode. So at least what I've been told so far is my expectation is, and I obviously haven't tested this yet, is that if I stick it in reverse charging mode and then I put my vehicle in storage for a while and I don't start the vehicle, it'll keep the vehicle battery up and running from the solar that's plugged into this thing or the solar that's plugged into your power station, depending on how you have it connected. So, useful feature. Charger 1, by the way, did not have this feature. Very nice. Portable power station charging voltage. We're going to demo this in a minute. But effectively, there's 3 modes. Smart, manual, and custom. And I'm going to show you what all 3 of these do in a couple of minutes when we get there, because this is where a significant portion of the brains of this new unit are being displayed. So that's kind of cool. Now we're going to demonstrate the smart charging mode that's built in here. So you can see I have the cable going from here to an Elite 100. I'm simulating turning on the charging as if I just started my car with the Elite 100 already plugged in. So I'm going to flip the switch here. And I'm told that this may take a minute and a half to start charging. I'll flip the switch. And I'll show you in the settings here. It is simply set to smart mode, smart detection. Didn't set it to this particular power station. I can tap down here. I'm at 9 volts. It's sort of figuring it out on its own. And I'm told this takes up to 90 seconds to figure out which power station it's connected to. There we go, it's just switched up to 53 volts. And charging has started. At a relatively good pace. By the way, the settings on the Elite 100 and the Elite 30 that you're going to see in a minute are both set to the default out-of-the-box solar charging modes. I have not changed the settings in there. So it just sort of figured it out, which is pretty cool. I'm going to reset this. We are going to use some time compression here just so that we don't have you sit around and wait 90 seconds for it to reset and then 90 seconds for it to find the next one. But I want to do this in one long take on purpose. Come on, turn off. There we go. Now it's off. Okay. Wait for the voltage to go back down. Don't want to unplug cables when it's got high voltage. Let us move the cable from one side to another. Pardon my reach in front of the camera. There we go. And you'll see I'm still sharing the app. I have not changed anything in the app. In fact, I'll go in there and show you. Okay. PPS charging voltage is still set to smart detection. I haven't changed anything. Now I've plugged it into a much smaller power station. And my PPS is now down to 2.4 volts. Let's turn it back on and see what happens. So now charging has been enabled again. And again, this might take 90 seconds for it to find whichever unit it's plugged into. And there we go. It appears to have found it. And notice how it has set the voltage lower. Interesting. Very interesting. So how does it do this? Well, there's no data connection on the solar cable, so that's not working. It's using a Bluetooth connection. And my presumption, Bluetti has not confirmed or denied this to me. It appears to be making an outbound Bluetooth connection to all of the nearby Bluetti devices and querying them for what is your solar input voltage, when it is outputting, as you guys noticed, a 9 point something voltage. it's trying to find which power station has 9 point something volts. And when it finds one, it assumes, because that's the voltage it's feeding out, that it is connected to that power station. Reads the serial number off that power station to figure out what the maximum voltage is, and then feeds it that voltage. Pretty clever, if that is, of course, assuming that's how they're doing it. But, you know, there is some evidence of this. When it first connects, you'll see a close-up here, you know, going back in time here, of when it first connects, it actually pops up the Bluetooth icon on all of the power stations nearby as it's doing its self-test when it's starting up, which is why it takes 90 seconds to find the power station. So it takes a little bit for this handshake. But the nice thing about this is it means that you don't have to remember what you set the voltage to. It'll automatically figure it out. Now, this is, of course, assuming this is how it works. This probably isn't going to work on non-Bluetooth enabled devices. The PPS automatic setting. Because there's no way for it to connect to Bluetooth, so it doesn't know what it's going to be connected to. Additionally, there's no way that's going to work on third-party power stations. So there's the other two modes as well, which we are going to play with in just a moment. Let's look at the other two charging modes, which are actually really the same mode, and they are really the same as what Charger 1 has. You can go into the charging voltage menu here, and you can tap on Smart Detection. You can either pick manual configuration or custom. If you go in manual, press OK. Tells me make sure you unplug stuff while you change it. So I'm going to go unplug stuff while I change it. Unplugged. Press OK. And you can pick your model number. I can pick Elite 100 in here. Elite 100, there we go. And it will set it to 56 volts, and I can hit done. And then it's going to make me wait 90 seconds for it to actually change the voltage, which we will use the magic of time compression, so you don't have to wait 90 seconds. Timer's done, so I can hit the back. Go all the way back out, make sure charging is off, which it is. I don't like plugging in live wires. So I'll just plug this in. Pardon my reach in front of the camera here. There we go. Now I will turn charging on. And it should skip that entire handshake and just start charging at 56 volts, which is exactly what Charger 1 does. There we go. In fact, it's faster than me even hitting the button to show you. So it just sets it to exactly what you told it to do. And it's going to start charging at whichever rate the solar generator wants to pull the power. Currently 4 amps, but it'll probably speed up in a second. The last mode to show you is the manual mode. So I'm going to go in here, go down to charging voltage again. Custom mode, excuse me, is the last one. Press OK. Give me the same warning, which I've already got the cable unplugged, so we're good here. Just set my charging voltage. Set it to 43 volts. Pick something random here. The other cool thing here, you can set your charging power. This is useful if you want to reduce the load on your vehicle's alternator. And this was the thing for a very small number of people with Charger 1, is their car had an alternator that was less than 130 amps, which was the minimum sized alternator in order to pull full power from Charger 1. Charger 2 lets you just set the number. So let's say your car can handle an extra 500 watts. Well, I can just go in here and type in 500. And there you go. And now it doesn't matter what voltage I set it to, it's not going to charge any faster than 500 watts. Pretty cool. So let's hit done. And it's going to make me wait 90 seconds. So let's do our little time compression thing here so that you don't have to. All right, we're done with our timeout. Back out here, it's still turned off. Let me plug the cable in. Now at this point it's going to be 43 volts. This will pull up to 20 amps. So that would be 860 watts. And I have it set to 500 watts. So let's see, it should not charge any faster than 500 watts. Go in here, there we go. We got 40.8, which I had it set to 43, so that's pretty close. Interesting, it's dropping my voltage down to 29. 8 amps. Give it a second for the voltage to recover. There we go, 15 amps. So we're now pulling 499 watts, which is interestingly exactly what I have set. It's 17 amps, 27 volts output, interestingly. So it's lowered the voltage some to ensure that my power is not any higher than what it is that I set. So yeah, very useful. This will allow you to use your Charger 2 in a vehicle that has too small of an alternator. Wouldn't be one of my videos if we didn't have at least one demonstration with a whole bunch of meters in it, and we're going to have at least several here, but this is our first one. So what we're looking at here is, let's play with the solar, which is down here. There we are. So what I have now is I have this solar cable plugged into my giant power supply. The giant power supply is going to feed in fake solar, and this is the car battery. So this meter here is reading off how much power is being pulled out of the car battery, actually in amps, and the second digit is 1 amp, so it would read in the 40s of amps. The meter over here, this one, this is the output of my big power supply. So there's no watts coming out of it, there's no volts, it's turned off right now. I have gone into the Charger 2 now, and set it to charge as fast as it can, the highest voltage it'll do and the highest wattage it'll do on custom modes. We don't have to sit around and wait 90 seconds. And additionally, I have gone into the Elite 100 and set it to charge in turbo mode. So it should pull as much power as it wants to. Let us go into Charger 2 and turn the charging on. I have flipped the switch. See over here, it's starting to pull power from the car battery. It's thinking about it. All right, it's now pulling 58 amps from our battery, and our fake alternator here just kicked on. That's that whirring noise the battery charger kicked on to keep the voltage high. And we're charging at about 680 watts going into the Elite 100. Next, let's kick on some solar. And I'm going to do this first at very, very low voltage, 12 volts, which actually wouldn't make a lot of sense for solar, but let's start really low anyway. Solar panels don't usually get this low, so let's start that up. So my power supply is now at 12 volts, and I'm feeding not much into it. 0.01 amps, it's not pulling very much. 0.1 watts, so 12 volts, like most Bluetti solar controllers, 12 volts is too low for it. So I'll turn this back off, and I'll set it up to 18. 18 volts, turn it back on again. Now it's going to feed up to 30 amps in here because it's a pretty big power supply. So we'll see what it decides to do. Notice it has completely stopped pulling power from the car battery entirely. Now it's going back up again. It's pulling 40. But it's also pulling 370 watts from my solar here at 20 amps. So even though the power supply can give it 30 amps, it looks like this is a 20 amp input, which is good because that's what an NC4 connector gives you. So it's not going to overload your input. And it's giving you basically the most you could possibly pull at this voltage. And it's pulling less power out of the car battery. Instead of pulling 58 amps, it's pulling 39. So that's good. Okay, let's turn the voltage up higher. Stop that. I'm going to set my voltage to 40 volts because this can handle up to 50. Give it 40. And now it is pulling much less power from the car. And 600 watts from solar here. So yeah, it definitely seems to be combining both solar power and alternator power and feeding the vehicle with both. So if you have a Charger 1 or if you didn't get a Charger 1, because the thing you were worried about is the fact that you have to unplug and replug your solar panels. Well, this appears to work. For our next test, we're going to check the wiring harness that came with the device to see how it handles extended high-intensity usage. One of the marketing values that Bluetti says of the Charger 2 is that you can drop in replace the Charger 2 from a Charger 1 without replacing the wiring harness. In other words, use the same wiring harness that came with Charger 1 for Charger 2. I have looked at this wiring harness here, and this is exactly the same wiring gauge that they ship with Charger 1. So Charger 2's wiring harness is the same as Charger 1. That's interesting because Charger 2 puts out more power. So the question is this wire going to get too hot? So how do we measure that? Well, that's actually pretty easy. We're going to use this entire setup here, which is why I have this giant car battery charger. And I have a temperature sensor right here that is running to a temperature monitor right up here. And we're going to record this session both on a video, time-lapse video, so you can see what happens, and do a graph and chart. And we're going to see how hot this wire actually gets. Now, I'm measuring the wire from this point right here on the outside of the insulation. So I'm not actually measuring the core temperature of the copper wire. I'm measuring the temperature of the outside of the insulation. Why? Really because we don't actually care how hot the wire gets. We care how hot the shield gets. I care if it's going to start the carpet in your car on fire. That's what I'm worried about. So let's test this and see if it gets too hot. We're going to let this run for, I think, 5 hours ought to be enough. I don't think a lot of people drive for 5 hours straight with the thing charging at full rate. And in order to make that work, by the way, because this Elite 100 will not take 5 hours of charge for full rate, we're going to put a load on the Elite 100. So we're going to abuse this Elite 100 at the same time because we're going to have a load on it of almost exactly the same amount that we're charging it at so that it doesn't get full. Let's try it out, see how it works. So as you guys can see, it's not 5 hours later, it's an hour and 40 minutes later. What has happened here is the Charger 2 didn't make it to 5 hours. It got to about an hour and a half running at full power from the alternator input only. And then Charger 2 itself cut back its output voltage down to 12 volts. Did not fire any alarms. My presumption here is that it got to a critical internal temperature and decided to charge the external device slower. You can see here it's actually still charging at 194 watts. So it's still working, it's just charging significantly slower now. So what my plan is I'm going to start the recording again. It is in fact still recording the temperatures, which of course isn't going to mean very much because the charging speed is slow that it's not going to heat up the wire. But what I'm curious about is how long is it going to take before it starts going faster again. So I'm going to keep an eye on the battery state of this Elite 100 here. And I'm going to have to turn on and off loads to keep that Elite 100 charging until the Charger 2 decides to start going faster. And we'll see how long that takes. That last experiment did not go quite as expected. So what I was hoping to do is let it run at full speed for, hours at a time until the wire got hot to measure whether or not the wire they shipped with the Charger 2 would overheat or not. Well, that's not what happened. What happened instead is it ran for about an hour and a half. The Charger 2 reached critical temperature, overheated, and then pulled back on the voltage that it was sending to the device that was charging, which basically slows down the charging. Now what's supposed to happen is it slows down for a while and then as it reaches a normal temperature again, it should speed back up. Well, in my case, it didn't speed back up. I had some conversations with Bluetti on the matter. They are investigating it as a firmware bug. So probably going to get fixed before the release, but as of this moment, it is not fixed. As I said, it's one of the things that happens when you test prototypes is they may or may not do what you expect. So did we learn something? Yes, actually, we still learned something. And the thing we learned actually, interestingly, was the thing we were originally trying to learn. Cable size. It's going to pull back on its charging speed long before the wires overheat. So for the folks that are worried that you need much thicker wires to prevent the wires from overheating, you actually don't. And the reason you don't is because the wire size isn't the limitation. It's the cooling in Charger 2 is going to reach its maximum before the wire hits the maximum temperature. Next up, we're going to take a look at this optional cable. You have to order this one separately when you get it. It's got a battery expansion port cable on one side, the P090D, and the other side goes into Charger 2. Let's figure out what this does. We now have the Charger 2 hooked up through the battery expansion cable to the side of this Apex 300 here in order to test that functionality. So you know what else is hooked up here? I have nothing hooked up to the solar input and nothing hooked up to the charge input. So the traditional solar inputs and solar output not hooked up to anything here. We're just hooked up to my fake alternator, and we're hooked up to the Apex via the battery expansion cable. We'll try the solar in a minute, but we're not there yet. Let's go into the Charger 2 app and turn on charging. Device spins up. In the app, you can see that power is flowing, and you can even see what percentage the battery's at. That's nice, because it does have communication here. On the screen of the Apex 300, you see nothing. Well, you don't see exactly nothing. You see a recharge icon and how long it thinks it's going to take to charge. But it doesn't tell you how much power is flowing. Interestingly, if we go back to the app, and you bring up the Apex 300 in the app, you can see the estimated charge time is there. So it has an idea that it's charging, but it's not showing on the screen that it's charging. If I tap PV, I see nothing. Well, it's not going through a solar input. In fact, interestingly, if I tap components here, it thinks there's a solar X connected to it. So that's interesting. Okay, it thinks there's one there. But there isn't. There's no solar X hooked up to it. So, interesting. So there's no way in the app actually to see from the Apex 300 itself how much power is flowing, but you actually can see from the app via the Charger 2 itself how much power is flowing into the unit. Similar to Charger 1. So that works. We are once again going to confirm that it prefers power coming from the solar panels as opposed to coming from the alternator. Here I have my alternator amp measurement on that side. So that's measuring power coming out of the battery. Over here I have the power coming out of my fake solar panels. Of course, the solar panels are turned off right now. We're pulling about 40 amps from the alternator. Let us turn on the solar. Now we have solar. Give it a second to start pulling power from solar. Pulling 13.5 amps roughly from solar, 540 watts. According to the app, it's pulling 530 watts, so roughly the same. Interestingly, according to this meter over here, we're actually putting power back into the battery. This is negative power, so we are currently recharging the battery according to the meter. According to the app, we're still pulling 50 watts from the battery. So that's an interesting discrepancy. I will have to discuss that with Bluetti later on. Almost certainly a little bit of a calibration issue there. But either way, we know for sure that it does in fact prefer power from solar, so we have succeeded the purpose of this test. Can Charger 2 do what its namesake says and charge two different solar generators simultaneously? So what I have here is I have my Apex 300 that's still connected to Charger 2 via the battery connection cable, the expansion port cable. I also have my little Elite 30 here. That's connected via the PV cable, solar input cable. The Charger 2 is currently set to automatic mode. You can see here in the screenshot from the app, smart detection mode. So we will see what happens when I start charging. So let's get that going. So I've turned it on. You can see the app shows that it's putting power into the Bluetti battery, and it is not putting power into the PPS, the portable power station. That's at 0. In fact, you can see the voltage here is 5.3. It's still trying to, in fact, you can see the little Bluetooth icon just came on here. It's still trying to negotiate. So let's give it a second. I'll come back when it's done negotiating in 90 seconds. All right, it's figured it out, and the noisy power supply that recharges my battery is kicked on. So we're now charging the Elite 30 here at 190 watts, 195 watts according to the app here. If I pop back out of the app, we're also charging the Bluetti battery at 486 watts. So yes, in fact, we can charge both at the same time. Very cool. and it's pulling 656 watts from the alternator battery at the same time. So yeah, you can charge two things at the same time. One downside of using the battery expansion cable here to connect to Charger 2 is that now we have no place to plug in the D1 hub, which would normally plug into the same slot that the Charger 2 is using. D1 hub, for folks that don't have the Apex 300, Apex 300 has no DC outputs on it at all. So if you're going to use it in an RV and you want 12 volt outputs or 24 volt outputs, you actually have to use this because there are none on the device. They put them all in a breakout box, but now they can't get to the breakout box. The solution to this problem, or Bluetti's solution, is a D1 hub with a different connector on the end that instead plugs into the back of the Charger 2. I don't know of any way to modify an original D1 hub, if you have one that's got the battery connector port on it, to get that to plug into Charger 2. It's a brand new D1 hub that's got physically a different port on the end. They do not have an adapter cable that I'm aware of. Maybe they'll make one, but at the moment they don't have such a thing. We now have the D1 hub here hooked up to Charger 2. I have it turned on. There's a button here. You can just push it, turn it on and off, or we can use the app, which we'll do in a moment. And I have a DC load tester here. This one's set for 300 watts at the moment, which I'm going to turn on, which is going to pull 300 watts out of the D1 hub, the Charger 2 version of D1 hub. While this is happening, the Apex 300 here is still connected to Charger 2 via the battery expansion port cable. So now I've got the alternator hooked up, I've got Apex 300 hooked up, I've got the D1 hub hooked up. Let's go ahead and turn on my load tester. And one very interesting note here, first off, in the app for Charger 2, you can see that I'm pulling power out of the DC panel. 345 watts, despite the fact that my charger is only pulling 300 watts. The other interesting tidbit, if you look at the screen, right there, you can see Apex 300 realizes that I'm actually pulling power from it, even though the D1 hub is connected to the Charger 2, not to the Apex 300. In fact, if I bring up the Apex 300 in the app, you'll see now it also shows that I'm pulling power out of DC. Interestingly, 311 watts instead of 340, despite the fact that the tester hasn't changed. So a couple of things there. It's not exactly the same in the different places of the app, but it's close enough. But I also have a DC power switch here under Apex 300, exactly the same as if I would have if this D1 hub here was plugged directly into the Apex 300 and not going through Charger 2. So the communication bus here is working. In fact, let me flip the switch here, turn off the DC output. You can see it's actually turned itself off. And my load tester switched off now because the load tester has no power anymore. So I can actually turn this off, and let's turn it back on here. Turn it back on. And I can turn it off and turn it back on from within the app itself, just as if you were plugging your D1 hub into Apex 300 on its own, without having it be separate. For this next series of tests, we're going to move into a real vehicle, my 2013 Jeep Wrangler. I have the Charger 2 installed, and installing it it took longer to find the screwdrivers than it did to actually install it. Due to the prior test, I'm completely convinced that my wiring is unbelievably overkill. So I didn't need to redo the wiring. I just needed to unscrew the harness from the Charger 1 and screw that same harness into the Charger 2. Easy. Just like the Charger 1, the Charger 2 shuts itself off after half an hour. I have left it long enough so that it does shut itself off. It's completely off at this point. I can't even connect to it on Bluetooth. It's off. And I have the Elite 30 here. It is turned on, because I've discovered in prior runs of this test that the automatic Bluetooth negotiation thing that is smart mode doesn't work unless the power station is already turned on. Interesting tidbit there. So let's try smart mode here first. Power on the engine and see if it starts charging on its own. Engine is started. And there we go. Now charging 180, 190 watts. 200 watts is as much as we can get into this thing. And it took about a minute after we started the engine before it actually started charging. Let's try that same thing with a different solar generator that has a higher input voltage range. Now we've got the Elite 100 set up, exactly the same settings inside Charger 2. I haven't gone in the app and changed the voltage or anything. We're going to start the vehicle. Engine is running, and as before, Charger 2 was completely powered down to the point that you couldn't connect to it in Bluetooth when we started here. Let's give it a minute or so and see if it finds it. There we go, it appears to have found it. Minute 14, so it was about 30 seconds into this segment when I said, so let's see if it finds it. So it took about 45 seconds this time to find it. Now we're charging along at 500-ish watts. Not bad at all. The next question is, does Charger 2 charge the solar generator while the engine is off? I have set up a massive solar array. Well, not that massive, but pretty massive. 3 PV200 panels, so 600 watts of solar here. Why do I have 3 PV200 panels? Because the weather is this. Yuck. We are not likely to get very much solar out of these at all. So I have set up a massively oversized solar array. Why? Because I want to make sure that we actually see something. Now, how do I have these configured? All 3 of these are running in parallel. So I've got 3-way adapters here. Walk over here so you guys can see. There we go, 3-way adapters. And that's running over to Charger 2. Now, is this going to be something you're going to drive around with? No, but could this be something you set up while camping? Yeah, it could be. And it does seem to be working. So that's awesome. Now, this is 600 watts of solar, and I'm getting 60 watts out of it. So, yeah, that's a thing. But, you know, the sun is what the sun is, and right now the conditions are terrible for solar. So, is what it is. I'm happy to get anything. And as you've noticed, the engine is off. So the question is, does it solar charge while the engine is off? The answer is yes, with some caveats, some barely significant caveats. The first one is, if you want it to wake up your solar generator, you're going to have to turn off smart mode. The smart charging mode that does Bluetooth interrogation of your device to figure out what's plugged in isn't going to work if the device is turned off, because there's no Bluetooth for it to connect to if it's off. So you're going to have to set a manual charging voltage in order to get it to wake up your solar generator. So that's the first one. Second one, does the sun wake up Charger 2 on its own? Yes. You can give it up to 50 volts. It's perfectly happy with up to 50 volts. It is not perfectly happy above 50 volts. So that's going to be another interesting challenge. This is a very constrained voltage solar controller. But it does wake it up, and it does charge with the engine off. Next one, does it solar charge while the engine is on? All right, let me go over here and start the engine. You can see it's currently charging with the engine off. Let's start it up and connect to it in the app. Has not yet detected that the engine has started. There we go. Now it's starting to pull a little bit from battery. It's pulling a lot from battery. Somehow giving more to the solar generator than it's pulling from battery. That's an odd reading. Is what it is. But you can see the solar power starts coming back up again. Now I'm only getting a trivial 15 watts out of PV here. But that's again because of my horrible solar conditions today. So yeah, charges faster with solar panels hooked up while the engine's running. Now, of course, if you're doing that, you're probably going to have the solar panels mounted to the vehicle instead of sitting on the ground next to it, but this works too for the test. Let's take a look at the D1 hub next. So I again have my engine off. I have my Elite 100 charging at 72 watts here, 73 watts from solar. And I'm going to turn on my D1 hub here to run my RV. And nothing happens. Yeah, it won't turn on. So why doesn't it turn on? Well, the D1 hub needs power. It needs a reliable source of power. My incredibly crappy solar day right now is not going to give it a reliable source of power. In fact, it can't assume that any solar is going to give it a reliable source of power. So it's not going to turn on from solar. It's also going to refuse to pull power out of the engine because the car's not running. That would just kill the car battery. So it's not going to turn on. It needs to have some power. But you say, oh, but it's connected to a solar generator. Well, this cable right here, that's a power input only. It cannot pull power back out of that. So there's two places that Charger 1 can get power from. It can get power from either the PO9OD cable right here, which is currently plugged into nothing, or from the car. In fact, you can see here, it's even blinking an error at me because it's not happy with its power setup. So you either have to have the engine running or you have to have a battery hooked up to it. And by a battery, I mean a Bluetti expansion battery, which we're going to do in just a moment to show the D1 hub working. We now have a little bit more equipment in here. I have the B300K, which is now hooked to the PO9OD port of Charger 2. I have a D1 hub, again, hooked to Charger 2. Off, by the way. This is a load tester, so I can put some load on the hub in a minute. And I have an Elite 100 that's charging at 900-ish watts. The car engine is not running. And I'm not getting 900 watts out of solar. The solar day has not gotten any better. So where's this power coming from? Let's bring up the app here. It is pulling power out of the B300K battery and putting it in to the Elite 100. In other words, it's discharging my main battery to recharge the secondary battery. That's pretty cool. So why is it doing that? Well, if I go into the settings here, I go down here to advanced, I can see priority charging. Which one would it rather have charged? The parking battery would be whatever's plugged into the PO9OD port, in this case the B300K. The energy storage system is, in this case, the Elite 100. So that's why it's recharging my little one off the big one, which is useful, actually. So if you've got a base camp set up and you want to bring a little power station somewhere and bring it back to your base camp and recharge it, you can actually do that here. And notice how you can do it at a relatively good speed, and notice how I don't need AC cords to do it. So that's useful. Still not going to be very efficient because you're charging one battery off another, but useful to do while camping. Next, I have the D1 hub here. And now it should work because I have a battery. So let's turn it on. It does turn on. And my little load tester here kicked on because that's what's powering it, is DC. Let's go ahead and turn on the load tester. The load tester is set to 300 watts. Put 300 watt load on it. There we go. Let's go back and take a look in the app here. Now we can see I'm pulling 1.2 kilowatts out of my battery, my B300K. I'm putting 800 watts into the Elite 100, and I'm putting 350 watts into the D1 hub. Oh, by the way, and the sun's sort of come out a little bit, I'm getting 68 watts of solar out of my 600 watt solar array that's producing 10% because the solar's so bad. But it's doing all of those things simultaneously. That's pretty cool. For this last test, we're going to do the same setup we had last time, except I'm going to start the car. So we currently have power coming out of the B300K into the Elite 100, out of the B300K into the D1 hub, which still has a load on it. And I'm going to start the engine all while this is running. Let's not turn anything off. Let's just turn the engine on. See what happens here. All right, now we get the car engine running. This is why you have to have an external battery here, because you'll notice that my load here didn't turn off. It's still running just fine. So if you had something running in your RV and you turned on the engine, you're not going to have all your stuff turn off. So that's nice. Let's go take a look in the app here. Now I've got power going everywhere. So I'm pulling 700 watts out of battery. That's the alternator. I'll tap on that. I'm pulling 60 amps out of my alternator, which is idling in the driveway here. I'm getting 79 watts out of solar. I'm putting 350 watts into the DC panel. 896 watts into my Elite 100. And of course the remainder is the battery. The only thing that's interesting is it's not... No, it is. It's animating. Power's coming out of the battery, not into the battery. Yeah, because I'm pulling 1400 watts out of here and I'm only getting 700 watts out of the alternator. So it's still drawing down my battery. Let me turn off the load tester and see how the animation changes here. There we go, load tester's off. That should reduce the load some. Now it's only pulling 170 watts out of my Bluetti battery, so it's still pulling power out of it instead of into it, but it's pulling 700 watts out of the alternator and 140 watts out of the Bluetti battery. Now let's make it stop solar charging here. Just unplug that. There we go. Okay. Now it's pulling power out of the alternator, 440 watts, and it's putting power into the B300K battery. It's recharging it. So all of this happens automatically, dynamically, based on your loads, and it just kind of seems to work. Congratulations, if you've made it this far, you've gotten through every test I can think of, which is almost an hour of testing, but it's Charger 2, there's a lot of stuff to test, so that's why it takes a bit. Let me cover a couple of best practices here, because I know folks are going to run into this. First one, which cable should you use? The PV cable, the P09OD cable, or both? Let me first just rule out both. Don't ever connect the same cable, the PV cable, and the P09OD to the same battery bus at the same time. If you have two separate units that are not connected to each other, sure, yeah, you can charge both units. I even demoed that. But if you have like an AC200L with two expansion batteries hooked up, don't connect the P09OD cable and the PV cable at the same time to the same battery bus, because it's going to discharge the battery through the P09OD to recharge it through the solar cable. You'll lose all of your energy with no benefit, so don't use both. If your solar generator can take the P09OD cable, that's the one you want to use. Just plain and simple. There's no advantage to using the solar cable over the P09OD if your solar generator can use that cable. If it can't use that cable, then you want to use the solar cable, and it comes with it in the box, so that works. Second concern, which solar input should you use? Should you use the one on your solar generator or the one on Charger 2? Well, if you're using the solar input cable to feed into your solar generator, now your solar input is used up. So the only input you have left now is the one on Charger 2. Let's say you're using the P09OD cable, the better of the two cables. Well, now you have two solar inputs you can use. You have the one on your solar generator, which isn't full because nothing's plugged into it, and you also have the one on Charger 2. So why not both? If you've got enough solar panels to plug into both controllers, use both controllers. There's no disadvantage there. So that's very cool. The D+ port, I'll call out ahead of time. I didn't get to test it. I have no idea what it does. Didn't get to test it. I don't even know what connector plugs into it. They didn't document that to me. So I have no content on how that works or what that's going to be. And I think that's going to be a big thing for folks that have smart alternators, figuring out how that's going to work. So there's sort of the edge there. What do I think of Charger 2? First off, comparing it to Charger 1. Charger 2 is, in my opinion, other than the physical size of the device, better in every way. If you've got a Charger 1 and you've got enough physical space to upgrade to a Charger 2, there's no downside. Even if you're not using the solar input, it's a better device. So clear win on the Charger 2 versus Charger 1. Now this, of course, there's more that goes into it too. There's price. How much is it going to cost? I have no idea. They haven't told me. I don't know what the release date is. I don't know what the price is going to be. I have no clue on any of that stuff. I'm just looking at it from a technical standpoint. Charger 2 is just technically a better device than Charger 1 in all respects. If you've got too small of an alternator, Charger 2 can do the job. Charger 1 can't do the job. If you've got a solar input where you didn't want to get Charger 1 because you didn't want to have to mess with plugging and unplugging cables, or Charger 2 just straight up fixes that problem. So very, very nice. Overall, yeah, I've taken the Charger 1 out of the Jeep that I have, and I've put the Charger 2 prototype into the Jeep. Even though the Charger 1 was a production model and the Charger 2 is a prototype, I'm happy to run that prototype because it's a better unit. So food for thought there. When would you not want to use Charger 2? Only one time I can think of. If you've got a setup such that you are charging faster than what Charger 2 can do. I'll give an example. In my truck, I've got a 3,000 watt inverter because I've got a ridiculously oversized alternator in my truck. Well, Charger 2 can't do 3,000 watts. And I don't think it would make sense for Bluetti to make a device that big. Most people aren't going to put that big of an alternator in their vehicle. So if you've already got a setup that's full-on custom and you can go faster than Charger 2 can, don't even worry about it. But for the vast majority of people, Charger 2 is a straight-up advantage over Charger 1. Straight-up upgrade. And I think folks are going to have a lot of fun with this. So hopefully that's useful. If you enjoyed this, then good, because I enjoy making these, and the reason I make them is because people enjoy watching them. So thank you very much for watching. Until next time.